Hi, my name is Garnet Gilmore and I'm the Director of Marketing and Sales for Warwick Forest. Today we're filming from the fitness center, and behind me you can see our pool. This is an indoor heated saltwater pool. It's about 90 degrees all year round, and there's also a hot tub tucked away in the back corner. Our residents enjoy water aerobics, relaxing, or just taking a little swim in the pool. We hope you're going to enjoy today's lecture. It's another very popular lecture that we have each year. Our speaker today is Dr. Bill Peach. Dr. Bill Peach was born in the old Riverside Hospital and has spent his entire non-academic life in Newport News. He received his BS degree in chemistry at the University of Richmond and his medical degree from the Medical College of Virginia, which is now VCU. He spent 2 years in general surgical training at MCV and then 4 years in neurosurgical residency, the last year as chief resident of the program. Dr. Peach became board certified and began his practice on the peninsula, where he had operating privileges at Riverside, Mary Immaculate, and Hampton General Hospitals. He was also a consulting neurosurgeon at Langley Air Force Base and the Veterans Administration hospitals. While on the Riverside staff, he was at one time chief of surgery and later chief of the Riverside staff. Dr. Peach taught courses for the nursing school and MCV senior students. Following his retirement, after over 30 years of practice, he became associated with Lifelong Learning Society both as a student and later as a lecturer on various medical and surgical related topics. Dr. Peach also gave lectures to various civic groups. Although he has been designated fleet surgeon of the Hampton Yacht Club for 20 years, he has yet to operate on anyone injured on a sail or a power boat. Welcome, Dr. Peach. We hope you enjoy your lecture.
Well, that started out well. My name's Bill Peach, and we're going to talk about the aging brain. And actually, this is not a good day for me to talk about it because everything got screwed up from the very beginning. I didn't get a lot of sleep last night, worrying about the talk. And I got up this morning, tried to get my notes together, and I could not get them organized in the way I wanted to at all. I went down and decided to shave, and when I looked in the mirror, my face had broken out with all these small bumps and scabs from this poison, this 5-fluorouracil that the dermatologist had given me. That wasn't good. So I went downstairs, kissed my wife goodbye, and then stumbled down the back steps getting out to the car. So in driving down here, I had this sort of epiphany. Well, first of all, why was I giving this talk? Why me? Why had Riverside Health Systems selected me? They have all of these young, brilliant neurosurgeons, neurologists, neurophysiologists, and they picked me. And then suddenly I realized why they picked me. They picked me because the title was The Aging Brain, and I was the most aged brain in Newport News, probably, that was qualified to give this talk. So that got me upset. So after I got here, I decided one thing. I decided that I would not give you a formal talk. So here are my notes from last night, and I'm going to tear these up and just throw them away. And what I'm going to do is give you not a discussion, because a discussion involves questions and answers. And as you know, I don't like to take questions during my talk. So I will give you a review of the problems that I've found within the last 2 years that are happening to my own brain and the research that I've done on that to try to decide, is there anything I can do about it? And this first happened actually in Lisa's class when I was standing there dutifully exercising and trying to ignore Charles Knox, who was always lifting more weights than I was, or trying to ignore Marvin Siquist, who could always stand on one leg longer than I could. I think that's because he has artificial knees, and I'm convinced there's a little button he can push that locks him in place. But anyway, that wasn't the problem. The problem was one of the women exercising next to me, I suddenly could not remember her name. I've been talking to her for 10 years, and there was a total absence of my ability to remember her name. No matter what, it wasn't on the tip of my tongue, it was a total blank, and that really bothered me. And then I began to remember other things that had been happening over the last 2 or 3 weeks where I sort of got lost trying to go to some place that I had gone many, many times. Now, granted, it was nighttime and all the store lights were off, but I still had trouble finding it. So these things bothered me, and I started doing some research on the brain and aging, and that's what I want to bring to you now. Now, I must admit, I looked at other factors that might age my brain prematurely. I was a good Southern Baptist boy, so the cigarettes and whiskey and wild, wild women never really affected me growing up. But still, I found in my research there were things that not only I could do, but that all of us can do to stop, if not completely slow down, the normal, so-called normal aging of the brain. And I'm going to share that with you. Now, since there are no handouts right now, but there will be delivered to you within the next day or two, I would suggest that you don't take notes, but just listen to what I have to say. The other thing is, as part of my research, I know that if you do take notes and listen to me, that you will have forgotten 40% of what I present to you by this Monday. And by next Friday, you will have forgotten 70% of it. So by the end of a month, you're not going to remember much of anything I've said. So the best thing to do is relax, don't take notes, and we'll send you copies of the PowerPoint. The reason I've had this title, Don't Let the Old Man In, and you've heard this in one of my other lectures, was that I saw a short on YouTube of a talk that Clint Eastwood was having with one of his friends at a restaurant. And Clint Eastwood is now 90 or 91, and last year he just finished writing, directing, and starring in a movie at the age of 91. And the gentleman eating lunch with him said, how do you do this? How is it possible for you to do this? And he said, I just don't let the old man in. Now, the fellow talking to him happened to be a songwriter. He went back, and you can actually listen to this song, Don't Let the Old Man In, which is very good. And Clint Eastwood actually put it into as part of the movie called The Mule. So that's where the song is, Don't Let the Old Man In. And that's what I want to do with all of us. And it's not just men, it's women. What can we do to try to delay the normal aspects of aging? Now, first of all, we'll talk a little bit about genetics because that's been in the news lately. Both genetics and a new field called epigenetics, which I will mention and try to explain to you, but I don't understand it very much myself. But we feel that as far as the aging of our brains, yours or mine, that about 20% of this is related to a genetic makeup. But only 20%. And this field of epigenetics is somewhat frightening because it may be that we may now be able to manipulate genes and alter this to some degree. But most of the changes in our brain are really related to a lifestyle. And we can alter that. I have started doing some reading on what's called Paleo Anthropology, which basically means that the reason that we are the way today is we inherited these characteristics, and they haven't really changed in the last 100,000 years, but our body is, we are doing things to our body that we were never evolved to have done to our body. And most of this involves in what we're eating and our lack of proper exercise. Just a few things. First, there is some difference between a chronological age, which is the actual amount of time that a person's been alive since birth. So you can give somebody your chronological age down to the very day you were born. More important, however, in that assessment is going to be your physiological age, and this is also called your biological age. And that age is what your body is actually functioning at, how well or poorly your body is functioning relative to your actual age. So what we have, of course, are some 50-year-olds that probably physically and mentally are functioning at 65 or 70. By the same token, we all know some people that are in their 80s and 90s that are functioning just as bright and alert, if not physically well, as people who are much younger, 60 or 70. So we're going to be talking about physiological age more than chronological age. Now, I put this up here because, you know, we have to face the fact that, like all beings, animal and mineral, that at some point we're going to die. This is a hydra. This is a animal, lives in fresh water, attaches to rocks, eats whatever comes by. The interesting thing is that of all my research, this is the only thing that I've found that can be immortal. A hydra, unless it's eaten by a fish or a crustacean, can literally live forever. And why is that? Probably because it has a specific gene that has enabled it to live that long. It's called the FOXO3 gene. Now, we have that to some degree, and we'll talk about how it affects our body. But this, if you want to see somebody that's immortal, a being, this hydra is it. Actually, a hydra was an ancient Greek monster that had many heads, and if you cut one off, two more came on. Now, if you can't be immortal, maybe you can be like this lady. This lady is Madame Jeanne Calment, lives in Arles, France. And this picture is taken when she was 121 years old. She subsequently lived to be 122 and a half. And so I read her biography because it was interesting. I wanted to see if she can live to be 122, just write a list of what she does, and that's what I'll do. Well, she was born into a reasonably well-to-do family, so she never had to work. She was able to go skiing and mountain climbing and all of that. Her father lived into his 90s, her mother into the late 80s, and her brother into his 90s. So she had a good genetic background. But she was able to take up fencing at the age of 90, and at 100 was still riding her bicycle. And she was living in her own apartment until she was 90. A funny thing happened at 90. Some entrepreneur came in and said, look, if you will give me your apartment in your will, I will let you stay there till you die, and I will also give you 360 euros, this is back in 64, every month for as long as you live, and I'll put it in my will as well. So this poor fella died about 24 years later, and his estate continued to pay her the money until she died 40 years later, 30 years later. So what did she do? Well, every morning she woke up at 7 o'clock. She said a prolonged prayer to God, thanking him for being, actually maybe her, but thanking God for being alive. She then had a very light breakfast. She then had a small drink. She then smoked a small cigarette and went about her business. And until she broke her hip at the age of 110 or so, she was able to walk around. She was later confined to a wheelchair. What were her favorite things? Chocolate, which she ate 2 pounds a week of, olive oil, which she not only drank or used, but put on her face every day. And then she went to bed at 10 o'clock at night. So anyway, for what it's worth, that's how she was able to live so long. So here's the problem. We are genetically programmed for a specific lifespan, just like a bird is, just like a dog is. We have a specific lifespan that seems to be built into our genes. Now, and the reason is because the cells can only divide a limited number of times. And some years ago, a scientist doing some work came up with the idea that our cells could only divide 50 times, 50 to 60 times each individual cell, and this was called the Helpik number, and it's pretty well what everybody uses at the present time. So how long does that mean we can live? Well, if you based it on that number and you disregarded diseases and war and famine and suicide and drug overdose, if you lived a good life without all of these things, he figured you could live, humans were programmed to live to be 150 to 160 years old. So we have a long way to go, because right now the life expectancy is in the low 80s, and for the first time, it's begun to go the wrong way. It's gotten less. Now, why is that? Well, some people blame it on suicides and drugs. I blame it on the previous administration, but people will argue with me about that. But one reason that we have that problem are these things that I've listed here. And I'm going to go over them in detail because these are the things that we can do something about. I wanted to show you what for purposes of learning something, I wanted to show you what a chromosome looked like. Now, this is a chromosome. It's a double helix. You've all seen pictures of them. The helix is composed of sugar and a phosphate. And then you have those little bars going across, which are different types of chemicals. I don't remember all of them. Quinine, cytosine, et cetera, et cetera. And you have 23 pairs of these chromosomes, and they're in the double helix form. So you actually have 46 chromosomes in 23 pairs. Now, if you took a portion of these chromosomes, if you divided it here and divided it way down here, and I mean, 2 or 3 segments down, 200 or 300 segments down, that constitutes a gene. And this whole process, chromosomes with the genes, is what, when people talk about a genome, that's what they're talking about. So all I want you to remember is that you have, 46 chromosomes in pairs, and then this double helix form, and a portion of a chromosome, which is made of DNA, is a gene. So these genes are affected by a number of things. And we'll go into these. Most of these are in the form of what we call free oxygen radicals, but we'll talk about that later. The second thing that can cause us to age, first being problems that affect the gene. The second, and this can be a number of things, as I said, but mostly free oxygen radicals, etc. The second thing that we have is a decrease in oxygen metabolism due to a decrease in mitochondria. Now, what I would like to do is talk to you a little bit about mitochondria. And in view of what I'm going to say, I want you to understand this. When we talk about dying, you and I used to think, and still do, think of organ failure. We die because our heart gave out. We die because our liver gave out. Some organ gave out. Actually, death comes from a much smaller scale than that. You have cells that make up tissues. You have tissues that make up organs. The failure to thrive and death actually becomes at a level within the cell. And so I'm going to show you a cell and the mitochondria in it, which are the most important thing in our body as far as maintaining life. This is a typical cell. You've all seen this in Biology 101. But here's the nucleus, et cetera, et cetera. What I want you to look at is this. In all of our cells, we have this mitochondria, and it's a membrane-covered organelle. This is the thing that creates the energy that allows the cell to function, that allows the tissue to function, that allows the organ to function. And if these mitochondria stop functioning, if you get too few of them or they're inefficient in the way they function, then the cell dies and you die. Here's a picture under very high power, of course. Here's what the mitochondria looks like. So these are sitting in your cells. Their whole purpose in life, basically, the major purpose is to provide energy for the cell. And that energy is formed and stored in these little things right here, which store the energy in the form of STP. Okay, you see what they do. They take in oxygen, glucose, they can also take in fat, and what has happened is they put a chemical form of energy. Let me go back. A side effect of this is water and carbon dioxide. What I can't show you here, came off the slide, is one other thing that it puts out, sort of like the exhaust from this energy engine in here, are what are called free oxygen radicals. And these free oxygen radicals are the things that damage the tissues and the cells in our body and are responsible for progressive aging. Now, let me go back just a moment and discuss one thing. If we have a problem with mitochondria, what is it that we can do to keep the mitochondria healthy? Well, there are things that we can do, including proper nutrition. And there were certain things that you can eat that the mitochondria seem to like. They have affinity for chemicals called L-carnitine and creatine, and these are found in eggs and poultry and beans and nuts. So a diet should be loaded with that, because that's what the mitochondria like to ingest. The other thing that can do it is exercise. And that's the big thing, because exercise sends in more oxygen to these mitochondria. And they run studies where they can determine and count the mitochondria before and after extended periods of exercise. And yes, you can increase the mitochondria in your cells through exercise. A particular type of exercise, aerobic, but we'll go into detail as how you can accomplish this, hopefully in as easy a way as possible. So these free oxygen radicals come off of the mitochondria. Free oxygen radical just means that there's one electron that's been taken off the outer orbit of the oxygen atom. That removal of that particular electron makes the oxygen atom very irritable, and it goes around trying to steal electrons from other things, and unfortunately The other things happen to be tissues in your body, and the genes, and the arterial walls. Unfortunately, it also goes back and attacks the very thing that made it, which are the mitochondria. So much of the damage to our body and the cause of aging is due to free oxygen radicals circulating in our blood. Now, what can we do about free oxygen radicals? Well, let's pull up the next slide. And next slide up. Here's the free oxygen radical coming off from the mitochondria. It damages the cell membrane. It goes back and damages the mitochondria, and it causes changes in our DNA. Does our body have a way of handling this? Well, in normal circumstances, they do. That's why you have antioxidants in your bloodstream. And the antioxidants are in balance with these free oxygen radicals, and as long as they're in balance, things are okay. But when the free oxygen radicals become excessive, then the only way to handle this problem is to ensure that there are enough antioxidants circulating within the blood. And they have to be in their natural form, not in artificial form. So, second cause of aging, damage by free oxygen radicals, again, at a cellular level. The next, we have a shortening of the telomeres. Well, what's a telomere? Actually, a telomere is one of the things, remember that gene that I said allowed that hydra to live into immortality? Well, part of that mechanism is through its action on a telomere. So here's what a telomere is. Here's the, remember I showed you this, here's the chromosome. At the end of each chromosome, there are these protective tips on the chromosome. And these tips sort of keep it from unraveling, just like a tip on a metal or plastic tip on the end of your shoelace. So it's necessary for these strands of DNA to have intact telomeres to keep them present. Now, the problem here is that every time, here's a telomere, every time the body reproduces, divides and reproduces new cells, that tip is worn off a little bit, just a little. But remember, I said that you could go through 40 or 50 or 60 of these shortening of these changes in the cell during a lifetime. And every time that happens, the telomere gets shorter and shorter, and finally it disappears entirely. And the body can no longer keep up with its loss of cells. This is called senescence. Senescence is when your body begins to die off. And so what we try to do is figure, is there some way that we can alter this problem? And the answer is actually yes. Now, what is it that has been proven, to allow the telomeres to remain intact? And what that is, believe it or not, that's exercise. So if you want your telomeres to stay healthy longer, and you can count these, you can measure these, and they've done studies, and they found that if you do aerobic exercise, it protects the ends of the telomeres. Now, the other thing is that gene I mentioned, and that tends to protect it, and it does so by an enzyme called telomerase. Well, the idea is, well, let's get a lot of telomerase. Well, the problem is, yes, you can get it, but you can't control it. And what's happened is that in trying to use that, particularly in experimental animals, they get into problems with causing too much duplication, and so you have a malignancy develop. So that's still being tried, but at the present time is not successful in humans. So go back to the old-fashioned way and use the exercise. Now, like everything else, including my attic and garage and basement, you accumulate cellular debris. And it's this accumulation of cellular debris that can cause damage to the cells, particularly in the brain. And so the question is, what can we do about that? Well, I can't do anything about the debris in my carport because of my wife wanting to save everything. But the things that you can do with this cellular debris. What happens, and this is very quick, but in your normal cell within the brain, you have a complicated protein here. And if that happens to break in two because of some enzyme action, you're left with a beta amyloid segment here. And if the beta amyloid segments clot together, you get these amyloid plaques that are so common in Alzheimer's disease. Those plaques are called beta amyloid plaques. And they come from normal structures that have broken down as a part of normal living in your brain. Normal aging, I might add. And here these plaques are. And here they are around the nerve cells. Now, here's the big problem with Alzheimer's, is these plaques have been seen so frequently that the concept was that, well, these plaques are causing Alzheimer's. So a lot of the research recently has been getting rid of the Alzheimer's plaques. Well, there's a problem there. First of all, yes, people that have died had their brains examined and they had Alzheimer's. There was a high frequency of these plaques present. On the other hand, and this was done with a nun study where the nuns in this cloistered environment agreed to have their brains examined after death, they found that yes, people that died with dementia had a lot of plaques, but people that died with a lot of plaques also didn't have any dementia. And not only that, the people that died and had a lot of plaques did not necessarily show any changes during their lifestyle that would suggest the onset of dementia. So you can get these plaques even if you don't have dementia, and if you have these plaques, you don't have to necessarily have dementia. Anyway, the experience was that all the studies were trying to get rid of these plaques, and so far they found that that hasn't solved the problem, and in fact, some major drug companies have actually stopped that investigation altogether. So the other problem with dementias is this TAR protein. TAR protein comes from these microtubules that support the axon, or the nerve part, the lengthy nerve part of your nerve cell. And when these break down, they release a protein that is called tau, T-A-U. And this is very toxic. It's also seen in the brain. And as I say, it's been felt that maybe the beta amyloid and the tau proteins were all part of what's causing dementias, aging of the brain, abnormal aging of the brain, I should say. Again, this has not been proven, and studies so far in getting rid of tau and beta amyloid have not made any significant difference as far as the incidence of Alzheimer's disease. Okay, well, what can you do about this? You know, they're floating around there. Well, you'd like to wash it away. The rest of the body has a way of washing away the rest of our body has a way of washing away debris. It's called the lymphatic system. And you know about lymph nodes, etc. Well, the lymph is transported by vessels into the lymph glands and into the spleen, and they are able to screen out all the debris and get rid of it. The problem is that the brain does not have any lymphatics. So they're not able to continuously flush out the debris. Whether they're causing Alzheimer's or not, they have a hard time getting rid of it. Can we do anything about that? Well, the body is funny, but it has a way of getting rid of some of that. It has a way of the nerve cells shrinking and more fluid, spinal fluid-like fluid, flushing around these nerve cells and taking the debris out. It's not lymphatics. I think they might call it glymphatics, but it is a system of flushing of the brain to get this stuff out. Well, great. That's fine. Well, the problem is that doesn't go on all the time. The only time that flushing goes on is when you're sleeping, or to any great degree, it's when you're sleeping. And not only that, it's not when you're just snoozing or in light sleep. It's when you're in deep sleep, slow wave sleep. And unfortunately, as we get older and older, the time spent in slow wave sleep by adults gets less and less and less. So we'll talk about one way of trying to combat the dementias by altering sleep. So we're going to go a very quick anatomy lesson here because we need to get to other factors about the brain. Here's the cell body, nerve cell, the axon. This is what connects to other nerve cells. These are dendrites. You have maybe 50 billion of these cells. And these dendrites, these axon terminals will connect with dendrites of other cells. At the end of the cell, I'll put this up, you think that an electrical impulse comes down and jumps to the other cell. It doesn't. The impulse comes down. It releases what are called hormones that will cross this barrier and be taken up on the other side, and that initiates another impulse. These are called neurotransmitters. These are the neurotransmitters. You don't have to remember them, but I just want to tell you that these are 6 of many, many neurotransmitters. And these neurotransmitters are what many of the medicines that you take, say for depression and hypertension, work on. There are other nerve cells that support the neurons. These ependymal cells help strain things coming through the blood vessels, the so-called blood-brain barrier. These things put the insulation down on the nerve. The more insulation, the faster the nerve. In aging, the insulation gets less and less, so the nerve transmissions get slower and slower. The ependymal cells, help create the fluid. These are the ones that block toxins coming through blood vessels, and the microglia are the scavenger cells. They try to eat up all the debris in the brain. Here's the brain. This is what it looks like. It's shiny. It's very soft. You can actually, if you put your finger on it and push your finger right into the brain without any difficulty at all. You have 2 hemispheres. This is the top. We're looking down from above. From the side, this is the brain. It's divided into lobes. You can't see here. I'll show you another picture, but this would be considered the cerebrum, a forebrain. The midbrain is deep in here. This is the hindbrain or brain stem, and this is the little brain, which is the cerebellum. And I'm showing you this because there are 3 areas that tend to age more quickly. And they include the cerebellum, to a lesser degree, the prefrontal cortex, and then an area deep within this temporal lobe. Again, each area does something, This is movement, this is sensation, this is vision, this is hearing and understanding. This is looking at the brain from the pointer keeps disappearing. excuse that. Just another way of looking at the brain deep, going in from the front. The reason I put this up there is two things. This is the cortex of the brain. This is where all your nerve cells are, the gray matter. And this white are those axons, the nerve fibers coming from the nerve cells, and they come right on down and go down into the spinal cord. Notice the brain has connections from one side to the other, but what I want you to look at is this area right here, and this is called the Hippocampal Gyrus, and this is where most of the problems come with aging. This is the first area probably that begins to deteriorate. This is just something to show you the billions and trillions of connections between various areas of the brain. And here, as far as the number of connections, I read recently that the number of connections in your brain exceeds all of the telephone connections in the world. This is 28-year-old, this is 88-year-old. You would have to look closely, but these openings between the gyri or folds of the brain tend to get larger. Cerebellum's getting a little smaller. The frontal lobe is getting early changes here. This is a healthy brain on this side, and this is a human aged brain, probably near to the Alzheimer's type brain you would see. Notice all the shrinkage. Now, you say, well, that takes a long while. Your brain starts deteriorating at about the age of 30 or 31. And it gets progressive after that. Maybe every 6 or 7 years, you're losing 5 or 6%. So again, the hippocampus, this is where your memory is consolidated. It also is where you have what's called spatial memory, so you are able to navigate. People that have severe Alzheimer's, like on Golden Pond, remember with Henry Fonda, they get lost because they don't know how to navigate. Here's what the organ looks like, and that's why they call it the seahorse or hippocampus. And if you want to remember this, just think of the campus of CNN with a hippopotamus walking across it or something. Hippocampus. There it is again. There it is again. That's what it looks like. The other area that deteriorates is the prefrontal cortex, right in the very front of the brain. You'll get this handout so you can read all this stuff, but this is where your logic and thinking comes in, where you try to figure out problems. It's connected with the emotional center of your brain, but this is the last area in your evolution to develop properly. So if you want to remember anything, it's when we talk about the normal aging of the brain, it involves the first three structures: the hippocampus, the prefrontal area, and to a lesser degree, the cerebellum. These will be in your handout. It's just, these are the new studies, and this is why we know so much. These have all developed within, let me see if I can get it back. Within maybe within the last 5 or 10 years, these within the last 10 or 20 years. I put this up here just to demonstrate somebody's concept of what the female brain really looks like. And I only mentioned two things. One is the headache generator, which is sort of large, and the sex-initiated gland, which is sort of small. And as the man gets older and older and older, the headache generator goes down because he's having problems, so she doesn't have to initiate the sex in her. Anyway, I won't go into details with that. The man's brain is, you can see what a man's brain is. This is probably about a 45 or 50-year-old. The attention span has gone down. The listing is particle is almost non-existent. These are the various types of memory. And the reason I put this up here is that we tend to think of losing our memory, but we've got all kinds of memory. And what we have is sensory memory, what we see. It lasts 1 second. If you're driving to Williamsburg, you're seeing everything on both sides of the road. How often do you remember what's on either side of the road by the time you get to Williamsburg? You don't, because your sensory memory for vision only lasts that long. Your short-term memory and working memory last a matter of seconds to minutes. And the short-term memory would be when somebody calls you up and says, hey, would you tell Betty to call me back at 804-732-981? And so you say, okay, you hang the phone up. How long do you think you remember that number? Not very long. That's short-term memory. Long-term memory is exactly what it says. And you have some implicit memory that just pops up out of nowhere, out of your subconscious. I was doing a crossword puzzle and it said something about who were the Indians with General Custer, and I wrote Lakota. I've never heard the word Lakota in my entire life, but it popped up in my memory somewhere. In my unconscious memory, I must have come across it. Your procedural memory are things that you learn to do, and it can be knitting, it can be riding a bike, it can be playing a piano. These don't deteriorate with age. You can have a 92 or 94-year-old that's got Alzheimer's who can still play the piano in a very good manner. The memory that does deteriorate is called episodic memory, and that's memory of things that you have done or emotions you've had or people you've met, and that's one of the first that goes. So you'll forget about things that happened in the past, and you'll forget about names of people that you've just seen yesterday. This is the one that goes first as far as your memory is concerned. And your working memory, your short-term memory gets shorter. These others stay okay. In fact, they'll get better. Your ability to do a crossword puzzle improves with age, not decreases. There are two types of intelligence. People don't realize this. It's intelligence depending on what you study. And so if you go to college or you do a lot of reading, if you learn a lot of things, you get fluid intelligence. This helps you. The other is crystalline intelligence, and this is ability to, based on knowledge and acquired skills and study and experience, to properly run your life. Now, unfortunately, the crystalline intelligence decreases as we get older. So when we're faced with problems where we have to use logic and reasoning and so forth, we tend to slow down, whereas we still remember history quite well and some mathematics, etc. Just to show you, this is fluid intelligence, and this is crystalline intelligence, and it actually gets better as you get older. Now, these are the three things that change when we age in our brain. Processing speed. What do I mean by processing speed? Well, it's the speed at which we process new information. And you can read this on the handicap, but it's the reason that I have a terrible time trying to learn Windows 10 as I get older. My ability to absorb and remember new information and process it with other things I've learned in the past just slows down. So I end up getting a book called Windows 10, then I get another book, Windows 10 for seniors, and another book, Windows 10 for dummies, and I'm looking for one that's called Windows 10 for idiots. Your episodic memory means just that. These are episodes that have occurred in your life. It's recollection of events in the past. We just tend to forget those events if they involve you. This is not memory for everything. This is memory for personal experiences and memory based on meeting people even. This goes, and this is one reason why we have trouble with names and remembering things. Often it can involve days or months, sometimes even hours. You forget when somebody told you something an hour ago, but they're in your life specific. And executive function, I've mentioned this, it's the ability to control things, to take your working memory, to reason things, to plan and problem solve. This actually gets worse as we get older. I mentioned minimal cognitive impairment just in passing because this is a condition that may make you slightly more, increase the possibility for developing more severe degenerative disease. This is what maybe 20% of the people will have over the age of 70 and 30 or 40% over the age of 80. It involves problems with memory and maybe judgment, but that's all. You can still function quite normally. And unfortunately, this is one of the things that may be stopped with training, physical training and eating properly and so forth. But it is a risk factor, but they've shown that in some cases it can even be reversed. Cognitive reserve is the ability for your brain to take over if other areas of your brain are damaged. Some people have a lot of it, others don't. We see it in our practice where you have somebody with a severe stroke, blood clot, you know that areas of the brain have been irreparably damaged, and yet over time they learn to speak again. So there are areas of your brain that can take over functions they didn't have before, and that's called cognitive reserve. Can you increase this? The answer is yes, you can. So here's what you need to do. And you say, oh, I've heard this so much. They told me to do this for hypertension. They told me to do this for diabetes, et cetera, et cetera. Well, the point is yes, because it does help those things. And if you have hypertension, if you have diabetes, all of these things are going to affect the aging of your brain. But the point is that in order to achieve long-lasting results where you can slow down the aging of your brain, in some cases reverse some of this aging, these are the things you have to do. And you have to do all of them. You can't say, well, I have a proper diet and I manage stress so I don't have to worry about the others. The studies that have been run show that you have to do all of these things, and in so doing, you have a reasonable chance of reducing your chance of developing Alzheimer's disease by about 50%. 50% reduction in developing Alzheimer's disease. The exercise you must do is one thing. It has to be in some form aerobic exercise. And by aerobic exercise, I mean exercise that increases your pulse rate to a certain level so that it increases blood flow through the brain. Your brain is 2% of your body weight. Your brain uses 20% of the glucose and 20% of the oxygen of your body. So your brain needs more oxygen and circulating glucose in order to function properly. We know, and I've read the studies, that aerobic exercise will increase your brain volume, and it increases the connections between neurons. And what it does is stimulate changes in what is described as BDNF, brain-derived neurogenic factor. And this is the factor that allows the brain to create more blood cells. Now, when I was going through school and training, we were told you have all the brain cells you're ever going to have. You're not going to have any more. And we find out now that it's not true. There are areas in the brain fortunately in the hippocampus and maybe in the subfrontal area of your brain, where stem cells can develop into healthy neurons and nerve cells. But it has to be, the one thing that seems to do that is exercise. The Mayo Clinic, one of the doctors there was giving a lecture, and he said, right now, with all his knowledge, the only thing that we know that will slow down the development of Alzheimer's is exercise. Now, I had a little experiment. I found I walked the dog every morning at a certain time and at a certain pace to get aerobic exercise. I found over the last year or two that when I came back to do Sudoku, I could answer Sudoku to a higher level, 3, 4, 5 stars, if I'd done it right after I exercised. Whereas if I waited till 1 or 2 o'clock, I couldn't. And I thought that was strange, so I ran some experiments, and sure enough, that happened. Well, here's another experiment where they took some kids. This is just one example, but one group of kids, they had rest for 20 minutes. Another group of kids, they had exercise, and then they gave them the same test, and they took these scans. This is the scan of the kids that exercised. Their brain is lighting up all over back here compared to the kids that didn't. These kids scored significantly better on the same test that these kids took. And then they turned around, switched them, the same results. If you exercise, your brain metabolism picks up immediately. And so that's one reason that I keep pushing exercise. How much should you do? Well, right now they're saying they'd like you to do 150 minutes a week, 150 minutes of aerobic exercise. The aerobic exercise to get your pulse rate up to the proper level, I've told everybody this, one guide is 220 minus your age times 0.75. So if you're 75, this is about 116 beats a minute. Now, do you have to do this all at one time? Well, it's good if you can, but if you can't, you can do it in shorter segments. So as an example, I have a program when I walk my dog every morning that forces me to walk. That's why animals are good, not because they're cuddly, but because they force you to take them out and walk. And I know how far I have to walk in 10 minutes, in 20 minutes, and 30 minutes. Now, if you don't want to go through all of that, you're walking with somebody. If you can talk to somebody but can't sing, then you're probably at an aerobic level. I used to sing Staying Alive. I would walk, da-da-da-da-da-da, staying alive, staying alive. The other thing is, if you were ever in a marching band, 120 to 128 beats a minute. Neuroplasticity is the ability of certain areas of your brain to take over, as I said, and they can even do different functions, which no one has quite figured out. But we do know with elderly people that when you give a 30-year-old a problem and are scanning his brain, he uses either the right or left side of the brain. If you give that to a 75-year-old, the same problem, both sides of the brain lighten up. Your body does have enough plasticity that it's bringing in help from the other side of the brain. What do you have to do to get this going? You got to exercise. We talk about mental exercise. I have a gripe, okay, about learning, and not necessarily just lifelong learning. If you want to learn something, it's not enough to just go to a class. You can go in and sit down and enjoy the lecture and be entertained, and that's fine, but you really have not challenged your brain. As I said, you're going to forget everything, unless you've taken notes, unless you've gone home and reviewed the notes, unless you've actually thought of questions to ask yourself based on the notes. That's the way you're supposed to do it, just like when you were in college. So all I'm stressing is when you come to these classes, come with the idea that you're going to learn something and not just be entertained. Here's what they call it: productive engagement, not receptive. This is enjoying it, and this is learning something from it. You have to challenge your brain. Now, what do I do? Well, one of the ways of challenging your brain is I get memory exercises. I've written down a book, and I'll just show it to you if I can. I don't know if you can see it very well. No, anyway, that's okay. I have these notebooks at home called memory exercises, and I have various topics, and I leave it by my chair in the den, and when I'm not doing anything, I'll pick up this memory exercise book and just read something. In this case, I've got studies on evolution of man, Greek dramatists, Greek philosophers, Greek historians. These are things that I would never think of really doing, but I want to challenge my brain to remember these things. And that's what you've got to do. Here are the major challenges, and I've talked about this in the past. Learn a new language, learn to play a musical instrument, learn to paint, write a short story, learn to dance even. Memorize facts, events, and numbers, which is what I do all the time to try to keep my brain functioning, hopefully. Here's a number, the square root of 2. It's based on an irrational number, which means it never ends, you know. What I did when I started having problems was said, okay, I'm gonna challenge my brain to do something, and I'm gonna challenge my brain to learn the square root of 2, okay? I'm now out to about 60 decimal points. I can recite this to you blindfolded anytime you want, and I'm willing to bet $1,000 on it. And I want to get up to 100. So that's the challenge that I have, is to constantly work my brain, associate these numbers, trying to figure out how I can remember each group of numbers. I divide them into groups of 4 and then assign certain things to them. Anyway, 1356, the Battle of Poitiers and the 100 Years' War in France. I knew that in the past, and when that number came up, I don't remember 1356 anymore. I remember the Battle of Poitiers. So you can do that for everything. And it can even be sort of dirty if you want to, but anyway. Well, this is Mark Twain. The only way to keep your brain healthy is to eat what you don't want, drink what you don't like, and do what you'd rather not do. And that's exactly what I'm asking you to do. I'm asking you to exercise. We can talk about what you eat, but that's what we need to do. Healthy eating of your brain, for your brain. I listed these because we can't go over all of them. But the big one is fish. Of all the stuff I read, the biggest thing is that you should have fish at least once, preferably twice in your diet, and that's because of the omega-3. This omega-3 is one of the factors that does encourage new brain cell growth. It helps your heart and so forth, but this is why we're interested in it. And what I do is keep Alaskan salmon in my refrigerator all the time. And so when I want, sometime at breakfast, I'll eat it, sometimes at lunch. But we get in our household fish at least twice a week. And Betty has a great way of fixing any fish. Walnuts, omega-3, and antioxidants. I have a huge bowl of walnuts. Now, it's not where I can reach it with one hand. I have to get up and go over, but every day I grab a handful of walnuts and eat them. Yeah, they're a little fattening, so you got to be a little careful, but they're very efficient. Blueberries. Rather than go through all the berries, I picked the best one that is written about, and that's blueberries. So if you have to pick a blueberry, if you have to pick a berry, I pick blueberries. I have blueberries constantly in the refrigerator every day, so that if I want to eat some cereal, blueberries go on the cereal. Colorful berries, same thing with strawberries. We keep strawberries around. Now, listen, I could go crazy tomorrow, but I'm just telling you, this is the way, based on my reading, that I want to treat myself. Kale. I hate kale. I never ate kale. Collards. I hate collards. I really hate them until I told Betty about it, and she said, let me see what I can do. She's actually watches cooking shows 3 hours a day. She's a gourmet cook. She has found a way to cook kale and collards that is absolutely delicious, and I look forward to eating them. This shows you what it's good for. Dietary supplements, I hate to tell you this, but most of the studies say that when you take particularly vitamins and so forth, they really don't do all that good. The reason is they can chemically reproduce what the vitamin is, but they can't reproduce the micronutrients and other things that surround the vitamins when you take them in the natural state. So as far as I know, there's been no vitamin supplement. Our memory enhancement, those pills they advertise, have already been shown to basically not make any sense at all. What's the one proven supplement? And I go back to Madame Calmont, is virgin olive oil. I'd never eaten virgin olive oil. Betty cooks with it constantly, and now I have a bottle on the table, and I've given up those rich dressings that are so full of sugar and salt and use virgin olive oil. Some people just take a tablespoon every morning. And I'm not going to go through this. The newest diet, and the word diet shouldn't be used, it should be meal plan, is this diet which is supposed to help your brain. And it's a combination of the Mediterranean diet and the DASH diet. Now they have the MIND diet. So you can copy this off your handout. The things that you should avoid, I'll make a point of this because I've done extensive study, is on sugar. And even if you don't put sugar on it at the table, almost everything that I looked at in the grocery store had high fructose corn syrup. That's the worst thing you can drink, the very worst. And it's actually considered by many very good scientists as a poison. And I won't go into it as to why, but they convinced me. I've just said this. That's a pretty interesting statement to make. But we worried about brain aging. This is what the research right now shows. The next thing I had mentioned, that the brain doesn't get rid of its debris until you're sleeping. Well, oops. Are we still okay over there? Okay, because I've got another something over here. We now sleep 2 hours less than we did a century ago. And that's bad. I have friends in lifelong learning that said, I can get by with 6 hours sleep. Well, the point is you can get by with it. I'm not questioning that. I'm questioning the fact that all the science now, with a few exceptions and a couple of people that I've read, feel that you need to have 7 to 8 hours sleep a night, period. And it does have a significant effect on cerebral functions. So don't tell me you can get by on 6. The only people that can get by on 6 have a specialized gene, I forgot the name of it, and that's present in 1.2% of the population. Now, what happens when we sleep? Well, we go through different ages of sleep. The two important stages, and we'll go through it, or what's called Rem sleep, rapid eye movement sleep. And that's where we consolidate all the information we've accumulated during the day. That's where we dream. That's where we come up with ideas. Have you ever awakened in the middle of the night and suddenly a problem you had was solved? Well, there are any number of composers and scientists that have testified to that. The periodic table was discovered during sleep. It suddenly popped into the guy's head. Some of the Beatles songs just popped into their heads. They woke up and they wrote them down. So now what happens is that the brain during sleep is not able to metabolize sugar well. So it gets its energy source from glycogen, which obviously is then transferred to sugar, but the glycogen is stored in the microglia. And the renewal in the microglia of this glycogen takes place during sleep. So if you want to maintain proper storage of energy sources, particularly sugar and glycogen, you've got to get 7 to 8 hours sleep. I mentioned the flushing out. This occurs during deep sleep. If you want to have your brain flushed out, you've got to get enough sleep. These are the different stages. I'll let you look at your handouts on these. You can check them when you have an EEG on. I've had an EEG done a number of times. But you go through these various stages. Stage 4 is very, very deep sleep. And they're slow waves. We call it delta wave sleep. Stage 5, you're morbid. And here are the stages. You go to sleep, you're getting drowsy, you get into this stage and your brain turns off visual and auditory stimuli. You get down here and now you're in a pretty good stage of sleep, but you've not reached deep sleep yet. And that's a very short period of time, and then you work your way back up. And this red line is Rem sleep, rapid eye movement sleep. And then it goes back down. So you get your ideas and so forth up here. As you get into this stage, you take those ideas and memories and implant them in your brain. And when you get down here, you flush your brain out of the toxic materials. So you need all of this. Unfortunately, as we get older, we get less and less of this. And this seems to be mostly during the first 4 hours of sleep. So it's important if you can get to sleep properly. Well, it takes long to fall asleep. It's not as deep. We get up more times to go to the bathroom, etc. What can you do about that? Well, this is going to be in your handout. But the point is, have a schedule when you go to sleep about the same time every day. And I don't care if it's 8:30 or 12:30. And I have friends that do both. I said, use the bed only for sleep and sex. In my age group, I put in reading. Limit the time you spend in bed. Avoid caffeine beverages after 3 o'clock. Coffee is very good for you, as is tea, 3 to 5 cups a day, but please finish it up. Coffee has a half-life of about 5 hours, 6 hours. So if you took some at 8 o'clock at night, by midnight you still have over half the amount of coffee functioning in your brain that you had. No alcohol before 2 hours before. You might say, well, this helps me sleep. No, it makes you drowsy, but it really screws up your good sleep. And this is all this, I've done all this stuff. I have sleep apnea and discovered, my wife casually mentioned one day, dear, do you know that you stop breathing when you're asleep? I said, stop breathing for how long? She said, oh, 45 seconds or so. Well, you stop breathing for 45 seconds and your oxygen saturation really drops. So I did the studies. I had sleep apnea, fortunately severe. Fortunately, it was positional, meaning it only occurred when I was lying on my back. So I've discovered gimmicks that I've made up so that I don't sleep on my back anymore. But these are all things you can do. You've got to sleep. And these are things that can be done to help you sleep. I use earplugs. I use white noise generators. I keep the pets out of the bedroom. We have blinds. These are all techniques, and you can read these. You don't limit your afternoon nap. People say, well, I can catch up on my sleep, or I can catch up on my sleep on the weekend. No, if you have to wait till your weekend to catch up, you've lost it. What you missed by not sleeping soundly is gone. Medications, I'll have to tell you this, the sleep doctors, both the one I go to at Riverside Health Systems and everyone that I've read, said you should not use sleeping pills of any type, prescription or across the counter, that they don't produce normal sleep. And REM sleep might be lost. And in some cases, there are one or two that they feel might even shorten your life. Now, is there an exception to this? I don't know if I have it in here. No, let me just mention this. To give you a personal experience, melatonin is part of the body's chemistry that prepares the body to go to sleep. You can buy melatonin. It's not a prescription drug. You can get it across the counter. All the studies I read, with one exception, said we can't say that it helps at all. And you can get it in 1 milligram, you can get it in 10 milligrams, 15 milligrams. I then came across a study by the doctor at MIT that discovered melatonin as far as its effect on sleep. And he subsequently wrote papers on it and subsequently put his name on a melatonin pill. The problem is this. He said that it does help, but if you take too much melatonin, the receptors in your brain no longer will accept it. And a lot of the studies done, the people were using 3 and 4 and 5 and 10 milligrams of melatonin, and after 3 or 4 days, the receptors in the brain just turned off. They wouldn't accept the melatonin. His theory was, you don't need a lot, 1 milligram, 2 at the most, but he recommended 1 milligram. And so later, I'm sure that he made him some money. They developed a capsule that was a slow release melatonin. It let a little bit go immediately and the rest dribbled off during the night. And so that's what I started using. I think it's helped. I'm not pushing it, but I'm just saying, when you talk about melatonin, you don't know how much is in the capsule to begin with, because it's not, the federal people don't have any rule over that. In his case, it's a patented drug, so you have to know how much is in it. If you want to use melatonin, give it a try. I wouldn't suggest using more than 1 milligram. It has a very short half-life of 2 or 3 hours. So if you take one at 10 o'clock, it's practically gone by 2 or 3. And that's why this long-acting, slow-release form, I think, might be helpful. I don't get paid for that. So, social activity, the answer is yes. People that don't have social activity don't live as long as people that do. Men over the age of 70 that are living by themselves don't live as long as men who, if not married to somebody, are living with them or around them a lot, live shorter lives. You need to have social activity. And that's why lifelong learning is good. Stress does have a detrimental effect. It causes high levels of glucocorticoids. These damage neurons in the hypothalamic area. And chronic stress causes shortening of those very telomeres that I told you shouldn't be shortened. How do you manage the stress? Any of these things. To give you an example, aerobic exercise is great. If you do an aerobic exercise every day, the scientists have said that does you as much good as one antidepressant pill. That doesn't last for days. You got to do it every day. But they assured me in the research that that's an excellent way of managing stress. Mindful meditation, deep breathing. I do this. Yoga, Tai Chi, and I put YouTube videos. Under YouTube, there's a video called Relieve Stress in 10 Minutes Flat. And it's great. I like it, and I use it a lot. All right, I'll leave you with this. This is a Doonesbury article that I really like. So that's the way I feel about using my telephone for getting a lot of information. I'd rather have it available. Hang on. Okay. We should never stop learning, and that's why we're thankful for the Lifelong Learning Society. But you've got to use our society properly. You've got to take advantage of the exercise programs, the meditation programs, the language programs. And when you go to these courses, don't just sit down there on your behind and be entertained. You've got to make an attempt to actually learn something and remember something from what's being given you. So thank you.